Hello, welcome back to MEC 416/816 Engineering Acoustics. In this lecture, we're going to talk about the wave nature of the general solution for the elastic wave equation. So we're going to consider here just a general solution G of Ct minus x. This is equivalent to x minus Ct. You can use either of these. We're going to then consider what the wave looks like at a time t equals t1. So at this time, our wave is going to look something like that. It's going to have here an amplitude, let's just say of A. This is our function g of ct1 minus x1. We can see that we're here at a position of x1. And then at some later time, t equals t2, our wave will have moved over here. Still have an amplitude A, and again, this is the function here is g of ct2 minus x2. And I'm going to need to move this little a on over to the side here. But we're again here, we're at a position x2. And the distance between these two is going to be c times the quantity t2 minus t1. Okay, so the point here is that this function g is a wave that will travel over time. It tends to be localized in space, and then it moves through space. It doesn't necessarily have to be localized in space, but it's easiest to visualize when it is localized in space. Okay. So that particular solution that's found at x1 when t equals t1 is then repeated at x2 when t is equal to t2. And so what that tells us is that g of ct1 minus x1 is equal to g of ct2 minus x2. Or, more importantly, that ct1 minus x1 is equal to ct2 minus x2, which can then be rewritten as the following. We can write this as x2 minus x1 is then equal to c times t2 minus t1, which is what we saw above shown here. And I've now drawn that in there. This then results in the following, that c here is equal to x2 minus x1 divided by t2 minus t1, and it's in here called the phase speed of the wave. It's the speed at which that wave travels down the system.